Good morning, ladies and gentlemen. I'm pleased to be here with you, and I want to thank Ryan and Pool for that great organization and giving me the opportunity to be here with you and connect with this elite group of fire life safety experts. I'm going to share with you some technical information about the special fire life safety requirements for the rail projects, including the metro stations and trainways. I know that I have only 15 minutes, so I'll try to make the presentation as fast as possible, and also I will try to share as much information as I can. We will start by answering this question: why the fire life safety is important in transportation industry. The metro station is a special assembly building because it serves and hosts a large number of occupant and passenger from different age group and cultures. So we cannot estimate the behavior of the people and the passengers, including in case of fire and emergency cases. So a special consideration shall be taken while estimating the fire life safety requirement, both the passive and active, to make sure we are having a tenable condition for the people during evacuation. Working on the fire life safety for a metro project means that we are working on the fire life safety for the stations, the railway, and the maintenance depot. This is a typical layout for a metro station, including the entrances and the station hall and the platform. From here, we can see that the station has 4 entrances leading to the station hall that we call it the concourse. From the concourse, the people can pass the AFC gates, moving to the paid area. This area, we are calling it the unpaid area. For the unpaid area, the people can just use it to pass to the other part of the or the other side of the route. If the people pass the AFC gates, that means they are in the paid area and they can use the vertical movers or the stairs to access to the platform that can be at high level for the elevated station, or they can move down for the platform for the underground stations. Station can be open or can be enclosed. So for all fire life safety experts who are going to set the fire life safety requirement for the station, they need to be careful, because fire life safety requirements for the enclosed station are different from the open station. Station types. Metro station can be elevated, underground, shallow depth, at grade. And the fire life safety requirement, both the active and the passive, are different for each type, as we will see in the next slides. Station can be transfer station, where the people can transfer from line A to line B, and the most popular transfer station in Riyadh is, of course, the KFT station, where the passengers can move or can transfer between 3 lines. The applicable codes and standard. The applicable standard for the metro station or the rail project is NFPA 130. NFPA 130 is the standard for the fixed guideway, transit, and passenger rail system. But still, the regulations and other codes like NFPA 101, SPC 201, and SPC 801 still applicable for the general fire life safety requirement. For the tunnels, here just I wanted to highlight that there is a difference between the rail tunnel and the road tunnel, because in some of my previous discussions with some consultants, I realized that they are using the NFPA 502 for setting the requirement for the rail project. For the rail tunnels, we are following NFPA 130, and for the road tunnels, we are following NFPA 502. The fire source. Fire source depends on the fire events or the fire scenario expected in the stations. The fire scenarios, we have different fire scenarios in the stations, we can estimate that we are having fire scenario on the platform, on the concourse, and on the technical areas, and also we are having fire scenario on the tunnel. For the fire scenarios inside the station, on the platform, or on concourse, the expected fire source is a luggage fire, and this is between 1.5 to 3 megawatt peak HRR. For the tunnel fire, the expected fire load peak HRR is between 7 to 30 megawatt for a train fire, and this number is based on the information collected from the train manufacturer. We will now show some of the special fire life safety requirement from NFPA 130, and we will start by the passive fire life safety requirement, the main occupancy. The main occupancy for the metro station, based on the activities inside the station and based on the classification of SPC, is assembly group A3. But the station is a mixed use or a multiple use occupancy, and other occupancies can be found in the station, like F2 factory occupancy for the plant room, the M occupancy for the mercantile or the retail space, and the B business for the staff room. The point of safety. It's very important to know where is our point of safety while considering the fire life safety. The point of safety for the metro station, we have 2 points of safeties. We have a point of safety for the people evacuating the platform, and in this case, the point of safety is the concourse. The concourse level, as per NFPA 130, is considered as a point of safety for the people evacuating the platform. And for the people evacuating the concourse, the point of safety is the external of the building. So when calculating and considering the travel distances for the means of egress, the travel distance for the people evacuating the platform shall be calculated up to the concourse, and from the concourse shall be calculated up to the external of the building. Occupant load. NFPA 130 has a specific requirement for the occupant load and travel distance and evacuation time. The occupant load for the stations, in general, the station needs to comply with the means of egress requirement in 101 Life Safety Code for new assembly occupancy, except where it is modified in NFPA 130. Travel distance on the platform maximum shall be 100 meter, and the common path shall be 25 meter. Evacuation time. As per NFPA 130, we have 2 evacuation time. We have the evacuation time to evacuate the platform, and we have evacuation time to fully evacuate the station. And evacuation time to evacuate the platform maximum shall be 4 minutes, and to totally evacuate the station to outside of the station shall be maximum 6 minutes. Platform corridor. The NFPA 130 has a specific requirement for the platform, like the capacity for the platform corridor shall be maximum 2.08 person in inch minute, and the minimum width for the platform shall be 1,120 meter. And the escalators, as we all know that escalators, as per NFPA 101, cannot be used as a means of egress, cannot be considered while calculating the means of egress. But as per NFPA 130, the escalators can be considered in our means of egress under some conditions, and these conditions are listed in NFPA 130. One of the conditions that all the escalators shall be constructed from non-combustible material and can be remotely controlled. Exit hatch. Exit hatch is a very important element in the means of egress for the metro stations. Exit hatches are used in case of evacuating the platform direct to the street level. And in this case, after reaching the street level, the people can be evacuated by a head house, or in case it is impossible to provide a head house because of the location, or because of some circumstances in the location, we can use a exit hatch, and the exit hatch has some specific requirement in NFP 130. And by the way, you can see that exit hatch all over Araya Street, where the passengers are evacuating direct from the platform level up to the street level. Automatic fare collection. Automatic fare collection is a very unique and special part in the metro station. We all are aware, of course, of the automatic fare gates. Automatic fare gates has some specific requirement in FB 130, and it shall be integrated with the fire alarm of the station to be automatically opened in case of fire and be used in the means of egress. Platform edge provision, it is not required to have any guards or to have any PSD doors, but in case it is used like we are using it in Riyadh Metro project and also in Dubai Metro, in case it is used, it has some specific requirement, like the force to open it shall be maximum 50 pounds. Stairs and exit doors, as we all know that NFPA 101 has a specific requirement for the minimum width of the stair to be used in case of evacuation. NFPA 130 is setting a minimum requirement for the stairs and for the doors to be used in case of evacuation. The stairs, minimum width of the stairs shall be 1,120 mm, and the stairs serving the back of house shall be constructed from 2-hour fire rating. The doors for the back of house shall be minimum 8-10 mm, and for the front of house shall be minimum 9-10 mm. Sorry. Compartmentation. The compartmentation for the metro station starts from the external of the building. Like here, this is an entrance for a station, and here's existing commercial building. So the compartmentation of the external part of the entrance, fire rating of that wall shall be as per the requirement in FPA 101, NFPA 1, and in SPC 201 to respect this distance between the external of our entrance and the existing commercial building. Then we go inside the station, and the compartmentation between the different occupants inside the station, like the public area and the retail. In this case, if the retail is more than 10%, it is not considered as accessory use, so we have to respect the fire rating between the two occupancies. Also, the protection of the vertical walls, including the stairs and the elevator shafts, and then the protection of the ancillary space and technical areas like the FCC, the electrical rooms, and fire pump room. Now we move to the active. We finish the passive part, and we move the active fire and life safety requirement, and we will start by the fire alarm and notification. The station shall be protected by an addressable fire alarm system, and the system shall be interfaced with other systems to make sure to trigger the required actions during the emergency, like the smoke extraction, staircase pressurization, and notifications. The station shall be as assembly building, serving and hosting a large number of occupants. The station shall be provided by public address system for communication with the passengers and employees in the event of emergency. Fire suppression, as per NFPA 130, the station shall not be fully sprinkled. The automatic wet sprinkler system are required to be provided in certain areas of the station, like the trash rooms and storage room. But as I remember, in the new version of NFPA 130 2023, they are providing now more areas to be protected by the wet sprinklers. This is for the automatic part. For the manual part, NFPA 130 is asking for class 1 or class 3 standpipe to be installed inside the station, and of course the class 1 landing valve to be provided in the surface stairs. And of course, the fire hydrant and the fire department connection shall be provided as required by SPC 801 for the assembly building. Usually for the metro stations, we are providing two sets of fire pump. The first set is to protect the inside of the station, including the fire sprinklers and the fire hose cabinet, and the external set to supply the water to the manual fire hose cabinet on the track side. Smoke control. Smoke control for the station. Smoke extraction shall be by a mechanical ventilation system using smoke fans. But as per NFPA 130, if CFD analysis is done for the station and can demonstrate that the natural ventilation is enough for the station, so in that case we can use the natural ventilation to extract the hot smoke. Fire command center as per NFPA 130. That's why we had the previous slide that showing the different type of stations, because the fire command center as per NFPA 130 is required only in the underground station, and the FCC fire command center shall accommodate all features listed in SPC 801. Standby power, the standby power. All standby power shall be provided in the metro stations, including the diesel generator, the UPS, and the CPS. All the critical fire life safety equipment like the fire pump and the smoke extraction fan, staircase pressurization fan shall be connected to the diesel generator. All the special rail system shall be connected to the UPS, and the emergency lighting shall be connected to the CPS, the central battery system. Egress and emergency access. Now we move to the fire life safety requirements for the rail tunnel. For the tunnel, we have to provide emergency walkway with a minimum dimension to make sure of safe and smooth evacuation in case the train stopped inside the tunnel and the people had to evacuate to the nearest station. Also, we are providing the active provision like the manual fire hose cabinets, and we are providing linear heat detectors and emergency lighting. Emergency and access within the underground enclosed trainway. The maximum, as per NFPA 130, the maximum distance which is allowed for the passengers to move in case of an emergency is 762 between the station. So in case the distance between inside the tunnel, in case the distance between the two stations exceeds 762 meters, we have to provide an emergency exit shaft so the people evacuating from the train can go on the walkway to reach either the station or the emergency exit shaft. And this is a typical cross-section for an emergency exit shaft inside the tunnel, where the people can evacuate using the surface stair up to the street level on head house or on exit hatch, as we discussed before. Smoke management inside the tunnel. Smoke management inside the tunnel is based on the concept of a pull a push-pull concept, and it can be done using jet fans or using huge fans located in the stations. Let's say this is, for example, this is a train on fire, and these are the two stations, and the train is moving in that direction, and we are having the fire at the front of the train. So as per the OCC Operation Control Center, they decided to move or to evacuate the passengers in that direction to avoid having the passengers passing through the fire. So in this case, they decided to extract the smoke in the opposite direction of the evacuation. So the fans will be working to extract the smoke in that direction. In this event, the people are decided to evacuate in that direction. So the OCC will run the fans to extract the smoke in the opposite direction of the passengers. The previous one is the case where the train stopped between two stations. But in the case of that, the train stopped at the station itself. This is a cross section on the platform. Here we have the platform level, and here we have the PST doors, and the train stopped exactly at the station platform. So the PSD doors will open to evacuate the passengers, and we will have over-track extraction and the over-platform extraction that will work together to extract the smoke, to avoid having the smoke moved to the other sections of the station. This is a typical layout for the smoke extraction fans on a station. Here we have two tunnel ventilation fans, and here we have the over-platform fans. In case the train stopped between two stations, let's say here is a train stopped, so we'll have the same station on the other side. So this fan and the other fan will be working on a push-pull concept to extract the smoke. In case the train stopped exactly on the platform, so these fans over the platform will be working to extract the smoke. As we discussed before, the fire protection and fire alarm for the tunnel. Yes, challenges in metro station. I have been working for Riyadh Metro project for almost 10 years now, and we had many challenges. I picked, because of the time, I picked only 3 challenges to discuss with you. Some of these challenges are not specific for the metro, but I picked it to share it with you, to consider it in your future design of fire life safety design for the buildings. The first challenge for the metro station is the limited station footprint. Most of the stations are constructed over a limited footprint, and for this kind of construction, it is very difficult to use the horizontal split case fan and to have the horizontal split case pump and the fire water tank, and it is very difficult to have the tank and the pump beside each other. So in this kind of construction, we are using the vertical turbine pump. So for most of the deep underground station, the fire pump used is a vertical turbine pump. And the second challenge was that the external separation between our station and the external of the existing building. Most of the metro stations are constructed in, especially for the old cities, are constructed in a very congested area. And of course, you will see that some of your, especially for the elevated stations, some of the entrances are very near to the existing building. So we need to make sure that the fire rating of the external wall of our entrances having a fire rating complying with NFPA 201 and SBC 201 and NFB 1 requirement for this distance. The last challenge is the PV panels. In case we decided or the client decided to use PV panels, please make sure that the design and installation of the panels are complying with the code requirement. Some designers doesn't know that there is a specific fire life safety requirement for the PV panels, but yes, there are some requirements in NFPA1 and SPC 801 for the PV panels, especially for the pathway between the panels and for the civil defense access.